Welcome. This DDI CADcast is part of our What's New series covering SOLIDWORKS 2013. This CADcast covers sheet metal functionality in SOLIDWORKS 2013. Some new functionality includes additions to the Feature Manager interface, the ability to use a single gauge table to drive multiple sheet metal bodies, the ability to merge notes and include complementary and supplementary bend angles in notes and bend tables for our drawings, locating enhancements for forming tools, and the ability to create a bounding box for any cut list item in a cut list. So let's go ahead and jump over to SOLIDWORKS and take a look at an example part. Within this file we've got a sheet metal feature and a weldment feature to illustrate the new features within SOLIDWORKS 2013. Notice that we have the new sheet metal feature in the Feature Manager that shows our first sheet metal body and the gauge table which controls it, a tab and a sketch bend, and then a single flat pattern within the new flat pattern feature folder. When we create a new base flange, we're presented with the option automatically selected to use the gauge table that is linked to this part. So when I create that, you can see that there is, within the new sheet metal folder, 2 sheet metal bodies and the single gauge table which controls them both. And then down at the bottom of the tree, within my flat pattern folder, are the 2 flat patterns. Within SOLIDWORKS 2013, there's an ability to take legacy files, meaning files that were created prior to 2013, and have them create that flat pattern folder for our feature tree. Just enable to create multiple flat patterns whenever a feature creates multiple sheet metal bodies feature found in the document properties option. This isn't necessary for files that are created in 2013, however. So when I have a multi-sheet metal body part, I can merge them with an edge flange using an up to edge and merge condition. And notice that within my sheet metal feature, or my sheet metal folder, I have the first sheet metal body and then the second sheet metal body that's embedded. Each one of those can be controlled as far as the gauge and bend radiuses for each one of those features. They can be controlled independently of one another. When I create a new feature or a new sheet metal body using that same gauge table, I can select from a different gauge. My cut list updates and the new flat patterns are added. Also notice that the new sheet metal features not indent but a separate entity. Because they're different thicknesses, my ability to merge the entities is obviously not available because it cannot merge the different thicknesses. But I can edit the new feature, change the gauge table back to something that matches the other features, and then I can easily merge them with an edge flange like I did previously. So let's take a look at what happens whenever we create a drawing and some of the new bend note features. So because this is a part file that contains both a sheet metal part and a weldment, I'm not automatically presented with a flat pattern option. However, if I go and select the select bodies and make sure that I select the sheet metal feature, a flat pattern view is generated for me. So notice that I've got the bend lines and the bend directions up and down. New in 2013 is the ability to add some controls to the bend notes. So if I go into create a bend table, you can see I can choose from alphanumeric controls, and I can add new columns. You can see that I've got items A, B, C, D, and E for my tags. Now if I want to change the way that the bend notes look, I can go in and change how my bend notes display. I can put them above the bend line, below the bend line, or with a leader. I have controls for all the different fonts and line styles for those arrows. Another new feature is the ability to add a column to my bend table that maps to some new properties that are unique to the bend notes. For example, complementary angle. So depending on which direction the operator needs to know for producing this part, I can produce both the complementary and the supplementary angle within my bend table. So let's take a look at how this would appear with just a straight annotation without regard to using a bend table. So if I delete my bend table, it automatically switches my notes back to the default bend values, keeping my leader settings. And I can go in and manually edit my note by including some very specific syntax. So the syntax is going to be open bracket, bend, dash, complementary, dash, angle. The spelling in this is very important since you're manually editing the note. There's not a way to go out and actually grab the annotation, so you can type this in directly. But notice that whenever I exit editing the note, you'll see that the complementary bend angle has been added to the note in brackets. I can also do this by editing the text in window through the right-click option. I'll go ahead and select the syntax that I just created, copy it to the clipboard, and then when I modify another note, I can easily paste it in wherever I want within my existing annotation. Now the warning that it gives about modifying the notes applies to things that I might have done, but because I'm using the system syntax, it will still remain parametric even though the warning message tells me that it's going to break it. For this particular syntax, it's actually driving it or pulling the information directly from the model. So notice that as I relocate my bend notes, the arrowheads behave as they would with any other annotation. Okay, switching back to the model file, there's an ability with bend notes in 2013 to merge bend notes that share a collinear edge. Now there's some specific functionality. Notice that within this model I've got a sketch bend and a tab. That sketch bend has always been able to modify or always been able to merge the notes. However, if you create a situation where maybe you've got two different edge flanges that do technically share a collinear bend line, however they're two separate features, notice what happens whenever I switch back to a drawing view. I have two different bend notes even though the bend line is collinear. By control selecting each one of the entities, selecting merge bend notes, I get a single bend note that's parametrically linked to my model. Likewise, if I control select two bend table notes, I can merge the bend tags so that I have a single node or a single bend tag. So the next thing to look at is the bounding box functionality in 2013. Notice within my part file, I've got a sheet metal item and a weldment item. By right-clicking on the cut list, I have the ability to create a bounding box. What this does is creates a 3D sketch around that specific entity. And if I look at the properties for that particular entity, you'll notice that I have 4 different notes: thickness, width, length, and volume. Each one of those items is parametrically linked to my 3D bounding box so that if my model changes, I can change it as well. If I rotate this model around and then highlight the bounding box, you'll see a little cube encompassing the model. This is going to be useful if you need to determine stock size for a machine part that's part of your cut list as well. So the last thing in SOLIDWORKS 2013 sheet metal to show you is the changes in forming tools. So making sure that my part is, or my forming tool comes from a forming tool library, I can drag and drop a forming tool directly onto my model. There is a new rotation angle option where I can rotate the forming tool. Previously I would have had to know the keyboard shortcuts. And there's also a new tab called insertion point that allows me to precisely place my forming tool. However, that's not always going to be in a location that's suitable for my particular design. So if I edit my forming tool feature within my design library component, there's a new tab called Insertion Point that allows me to adjust this sketch point. Notice that in this particular instance, there is a midpoint sketch relation assigned that constrains it. I can now freely drag that sketch point around, attach it to another midpoint of another entity, go ahead and exit the part and save it. And then whenever I come back to my model and instance another or the same sheet metal component, notice that the preview grabs it from the back of that forming tool consistent with where I put the insertion point in the forming tool feature. This allows me to use a dimension tool to place my forming tool accurately. Thank you for viewing this DDI CADcast. Please visit us at www.ddicad.com.